Guys, I'm back. So I'm gonna really need you guys to focus on this next part because this is gonna be my introduction to introducing you to electron configuration and how the whole process works, okay? So when we do electron configuration, I'm gonna run over here and get my table. Now, you should have already photocopied this right here, or not photocopied, excuse me, colored a copy of the periodic table that you got in class, or if you printed it out if you're digitally at home. So as you can see, I'm color coded into 4 sections, and if you look up here, it's also color coded into 4 sections. All right, so what we're going to be doing is we're going to be looking at the elements, and kind of like we have a DNA coding that identifies us, elements also kind of have a DNA coding that identifies them. You can look at an electron configuration for a particular element, and you can identify the element based off of its electron configuration. No 2 elements on the periodic table will have the same electron configuration, okay? So they're all unique, even though there's going to be some that have similar properties. For example, if you notice the colors, there's going to be some that exist within the same families and same colors. They're all going to be slightly different. Kind of like if you have siblings or family members and things like that. You're going to have a lot of genetic coding that is similar, but then there's always going to be that variance. There's a little bit of a difference because you are unique, you are individual. Well, elements on the periodic table are just like that. They are unique and they are individual, okay? So let's kind of go over what I mean by that. So if I look at the periodic table, I can see that it's broken up into 4 sections: S, P, D, and F. And that's the order actually that it's written in. Anytime you write an electron configuration, you're going to write it in the order that the orbitals exist. So S is first, P is second, D, and then F, okay? Now, when I'm looking at an element, there's a process to how you actually do that, okay? So when you're doing a configuration, you are going to write the row number first, followed by the orbital identification, the letter, followed by the column. So for example, if I were to write an electron configuration for hydrogen, okay, what I would do in this situation, hydrogen is located right here, okay? So if I'm writing a configuration for hydrogen, I'm going to write 1 for the row that it's on, S for the color sublevel that it's in, and then it's the first one in the S sublevel. So it'd be a column. So if I'm writing a configuration for hydrogen, it's going to be 1S1. Now, how do I write that? Okay, so I am going to show you an example. All right, let me get a table, and I'm going to kind of write how that would be on a piece of paper, and I'm going to show you. So for hydrogen, it's going to be row 1, S sublevel with a 1. So hydrogen's going to look like this, okay? Row 1, S sublevel, first column in the S sublevel, okay? Now, the next process is, how would I write a configuration for, say, helium, which is right next to hydrogen on the periodic table? Well, I'm going to do the same thing. Helium, which when we write electron configurations, helium is actually right next to hydrogen, okay? So that's why I had you color it the same color. So helium, once again, is going to be on row 1. It's going to be the same color, so it's going to be the S sublevel, but now it's in the second column of the S sublevel. So let me write that down and show you. So for helium, row 1, S sublevel, second column. So it's going to look like this, okay? Now, so I've just done all of the elements on row 1. So if I look at row 1, I've got 2 elements right here, okay? And my exponent here is a 2. So that's telling me that I had 2 elements. Now, if I want to find, say, lithium on the second row, so it's the very next element here on the periodic table, I have to write everything that came before lithium including the configuration for lithium. It's all included as the entire configuration. Now you say, why do you have to do that? Well, it's kind of like you as a person. If you're doing a family tree, do you just write you? No, you're going to include your parents, you're going to include your siblings, you're going to include your grandparents, your great-grandparents, and so on and so on and so on. So it's kind of like doing a family tree. You're going to be including everything that came before that particular element. Now, it's going to get cumbersome when we get all the way down here, right? Because there's going to be a whole lot of writing, and it does get longer. However, your genetic coding is also going to get larger as you get older, okay? So, what if we were writing the configuration for lithium, okay? So what if we were wanting to write that configuration? So for lithium, I have to include everything from the row before. So I'm going to write 1, and then how many colors do you see on row 1? You see 2, right? So when I start lithium's configuration, it's going to be 1s2, like that. And then I'm going to continue down to row, now we're in a new row. So I'm going to write my new row number, but we're still in the same color, so we're still in S. So I'm going to write S, but we are in the first column of S. So I'm going to write 1. So for lithium, my entire configuration is going to be 1s2, 2s1, okay? Now, go ahead and look at the exponents that I have here. I have a 2 and a 1. If I add those exponents together, that actually is going to give me the configuration, or excuse me, the atomic number for lithium, which is 3, okay? So if you ever get stuck when you're doing these configurations, you can add up all the exponents, and that should give you the atomic number of the element that you're looking for, okay? Now, what if we wanted to do the one very next to lithium, which is beryllium? Well, it's going to look exactly the same as lithium, except now, instead of writing 2s1, I'm going to put 2s2, because beryllium is in the second column of the S sublevel. So let me go ahead and write that down. So beryllium is going to look like this, okay? And as you're going to notice, I'm going to keep adding, okay? I'm going to keep adding and adding and adding each time I get a new element. Okay, so now that's beryllium. So if I add it up, 2 and 2 is 4. The atomic number for beryllium is 4. Now, what happens if I move from here? Okay, you always want to follow the order of the atomic number. So like when I started out at hydrogen, hydrogen has an atomic number of 1. Helium is 2. Now when I move down to lithium, lithium's atomic number is 3. Beryllium's atomic number is 4. Okay, so now I want to keep going with the atomic number. What comes after 4? 5. So I'm going to move over here, and I'm going to move over to boron. Boron has an atomic number of 5, okay? So I'm going to go moving left to right. You always move kind of like a typewriter or a computer, where you're going to go all the way to the end. Boom. When you stop, what do you do with the typewriter? It goes all the way back, right? What do you do with a computer? You go all the way to the end, and then you go down to the next row. And that's exactly how you're going to do these electron configurations. You're going to go all the way over. Once you hit the end, now you're going to go back to the left-hand side, but at a new row, at a higher row. Okay? So now we're going to go to boron. Okay? So remember, you have to write everything that came before boron. The nice thing is, though, you don't actually have to write 2s1, 2s2. When you write 2s2, that's incorporating 2s1. So for boron, I'm going to write 1s. How many of that color? 2. Now I'm going to go down to my second row, and I'm going to go 2s2. Now I'm going to go over here. Now, oh wait, I'm in a new color. Whenever you reach a new color, you have to rewrite the row number, whatever you labeled that color as. So on your table, you know, on mine, I colored the new sublevel green, and I put a P at the top of it, meaning it's the P sublevel. So this was the S sublevel. Now we're in the P sublevel. So anytime you reach a new color, you're in a new sublevel. So you have to rewrite the row number, the sublevel letter, and what column it's in. So here I'm going to go 1s2, 2s2. Now I'm going to write still second row, but now it's going to be P and it's the first one. So let me write down the configuration for boron. So it's going to be 1s2, 2s2, 2p1. So boron is going to look like that. Okay? Now, what if I want to get a little crazy and, not go to the very next one, but maybe, go over to fluorine, okay? So if you're looking at your periodic table, fluorine is actually located right here, all right? Fluorine is going to look very similar to boron, except instead of 2p1, it's going to be 1, 2, 3, 4, 5. It's going to be 2p5. So if I write the configuration for fluorine, I'm going to start at 1s2, 2s2, 2p5, just like that, okay? Now, what if I want to go down here? Okay, this is where it's going to get interesting, okay? Now, when they originally did the periodic table, okay, those elements and started doing configuration, those middle elements, these elements right here in your middle section, they weren't really derived in that way. The table had not yet been done. Mendeleev hadn't really done the table to this order yet. So what happened was when they started talking about the order in which you write the sublevels, S, P, D, F, that was all well and good for the first couple rows, okay, for the first 3 rows. But then once you got down to the 4th row, they're like, oh, wait a minute, we have a problem, right? Houston, we have a problem. Because what happens is you're actually going to get the D sublevel to the D sublevel before you get to the P sublevel if you're going in order of atomic number. So what they said is when they started doing that, they're telling you that in actuality, when you're looking at the orbitals, the D sublevel is actually in the 3rd energy level, but it's higher. It's in between S and it's in between 4s and 4p. Okay, so it's actually above there. So you actually don't get to 4s. You get to 3D before you get to 4s. Very confusing. Very confusing. So what I had you do is when I had you organize your table and draw your row numbers, you see how I had you draw 4 here, but then, oh wait, when you got to this new color, I had you put a 3 here. So anytime you're in the D sublevel, you're always a row behind. Now, do you have to memorize that? No, because you get to use this table. So you just need to remember, use what's in front, right? So if I'm doing 4s here, I go back down to 3D just for this color, and then back to 4 when I hit green. And that's why I had you number the green box as well, or the P sublevel area too, because that reminds you, once you're through the D sublevel, then you have to go back to your original energy level. Yes, it does get confusing, but what's great about this is it's a pattern. So anytime you're working in a pattern, it stays the same. So it's not going to change, okay? So when you're doing these configurations, it's going to stay the same each time. So when you know that you're a row behind, you always know, it doesn't matter which row within the D sublevel that you're in, it's always a row behind, but then when you get back to the P sublevel, you'll go back to your original row number, your original energy level, okay? So let's try to do one for, let's say, chromium. Chromium is element 24, okay? And it is going to be 1, 2, 3, it's going to be right here. So this is where chromium is, right where my finger is, okay? Now, I'm going to talk you through how to draw the configuration out. Then I'm going to draw it on the paper and show it to you, okay? Pay attention to how I do my hands so you can see, like, it's just like reading a book, okay? So I know that I'm going here, right? So I'm going to use my left hand and I'm going to start at the very top and I'm going to count over and show you how to write the configuration. So I'm going to start at the top and I'm going to say 1s and there's 2 there, right? So you'd start out as 1s2, so you write that down. Go to your second row. 2s, how many are there? 2, right? So you write that down, 2s2. Now, I'm still in the second row, but I'm in a new color. Anytime you're in a new color, you write the row number, the letter associated with that color, and then what column. Now, since I know that I'm going through the P sublevel, I know that I have 6 columns here. So I'm going to write 2P, and then I'm going to write 6, because I know there's six of those color, okay? Now I'm going to go down to the 3rd row, okay? I'm going to write the number 3, and I'm going to say 3S2, okay? Then I'm going to go over here in order and say 3P, there's still 6, so I'm going to say 3P6. Then I'm going to go down to the 4th row, and I'm going to say 4S2, okay? Now, remember, looking at your periodic table, you should see that in between S and D that you wrote row numbers. Remember, it's a row behind, so instead of writing 4D, I'm going to write 3, I'm going to write the letter, which is D sublevel, and then I'm going to go 1, 2, 3, 4, and I'm going to stop at 3D4. So let me show you on paper what that looks like. So 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D4. So that's what it looks like. Do you see that? Okay? So 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D4. And you're just going to continue on, okay? So say I wanted to go past D sublevel and I wanted to get to the F, okay? I'm going to take a commercial break and show you what that is, okay?